Howdy, howdy. Now, again, we're going to leave our test as is, and we're going to add a function called pipe. And pipe is cool because we're going to use the ES6 spread operator. It takes any number of functions and it's going to turn it into an array. So that's what this spread operator does. It's going to take essentially things that come in as separated like this. It's going to map them into an array of A, B, and C. That's all that's happening with the spread. Pipe is a curried function. It takes, I can't type. There we go. It takes a list of functions, any number of functions, and then it takes an initial input value that we'll call x. And with our array of functions, we use reduce, which is really just like the greatest function ever. It's kind of the Swiss Army knife of array transformations, which I really love. And this is already starting to get kind of long, so we'll break it to a new line here. Reduce takes a reducer function, and a lot of times you'll see it described as the accumulator and the element. In this case, our accumulating value is really just an output that we'll call y, and each element in the array is a function. With each function, all we're doing is applying it to the argument that is the accumulating value. And with reduce, we always need a starting value, and that's exactly what we use for x here. X is going to be our initial input. And so this is definitely kind of funky syntax. That's prettier auto-saving on me. So we take a list of functions and then an x, and then we have some like very abstract looking stuff here. But the high level thing that you need to understand, if that seems like a lot, is that we're just saying, hey, I want a list of functions and I want to pass it into, I want to pass an initial input into the first function in that array. The result, and that's going to be the first time through, y is going to be equal to x. And then we're going to pass that value into the first function. And in the next round of the iteration, y is going to be equal to the result of this application. So when we pass y into fun, the result of that will become the next y for the next function. So that can work for any amount of functions, and basically the output or the return value of one function on the left becomes the input for the function on the right, working from left to right. You may have seen similar functions known as flow or compose. I think flow also runs left to right in Lodash, and compose is the more mathematically pure version, which runs from right to left, which is how function composition often is described in mathematics. I like reading left to right, so I like using pipe. And I'll get to kind of this name is basically from a library that we can use, and all these will be replaced with library code. But pipe basically describes that it's a pipeline. So you take this like input value, and then you just kind of create this whole pipeline of function x, and then that becomes function of what would be like a y or something like that. One important thing to note is that let's just say that this is a function and this is a function and this is a function, and we take an initial input. This is kind of that right to left. So we'd say we would first call C with X, and the result of that would be we would apply B to that result, and then we would apply A to that result. So this is kind of, this looks fine with single letter variables, but when we get longer variable names, it can start to look kind of funky. And every time we add a function, it's just a little more hands-on that we need to like add things, and might be harder to reason about. So enough talking about pipe, let's use pipe. So here, our initial input, let's just say that the goal is to provide filter a function that just takes an item. Okay, so item is going to be our x. It's going to be our initial input. And we want to get to a point where we don't have to refer to it explicitly. So we're just kind of working abstractly with individual elements in a collection. So one way we can do that is we can say that we're going to say that pipe is going to take first a list of functions. We'll get to that. And then the last thing it's going to take is item. And this list of functions, as we can see, we have this whole kind of series of functions that they're not being composed automatically. So now we just need to kind of parse through equals and prop and figure out how to apply the arguments correctly and create an automated function pipeline. And now we're just going to slowly, so this was the item being applied to the prop function, and that's kind of confusing here. We just want that. So since item is coming in first, the first function in pipe should be the prop year function. Okay, so that'll be the first function. And we're just going to break to a new line. So it'll read left to right and top to bottom. So item is going to, I'm just going to delete this for now. Item is going to get passed into the pipeline. Let's see if we can write this a little easier. Nope, prettier likes to do its thing. Let's say here, right there. So we can see it a little more clearly with pipe and like which level, which are the first stage of the arguments, which is the second stage. And so item is going to be that initial input. And now we just need, it's just a matter of building up function after function after function. And in this case, item is going to go first into prop year, which when prop's given its first value, it just returns a function. Oops. Hitting enter instead of slash. Just returns a function that takes an object and calls object.year. So the return value of this is going to be an integer in this case. Or number, we'll just say number. Okay. So we want to pass that number into equals year. We already have year available to us in the scope of this function. And so we want to pass the result of calling .year on item into equals year. And that becomes itself a predicate function, right? Because now we're just returning true or false. We have an initial input. And what's sweet is now we have that same pattern where if we do bring it up to one line now, we can see that this anonymous function, all it does, what is it? When does it actually use item? We get pipe prop year equals, oh, it just comes last as its own invoked argument. So we can delete the explicit reference because pipe itself represents all of this is the first stage, basically the funds stage. Oops. And now we're just waiting for X. In this case, it's going to be an item or a book. And we don't have to actually reference it. So pipe is a function that takes an object, it calls the year property on it, and it takes that value and passes it in the equals year. And that itself is a predicate function. It's because it returns true or false. Equals is going to use that and return true or false. So that's prettier again, just doing its thing. We have filter, it takes one argument. That's a predicate function. The predicate function is pipe, which takes two stages, prop or function, a list of functions. In this case, we have the prop year function, equals year function. Both of these are two-step functions. Each take one argument at a time. So here, when item comes in, prop will be fully executed and we'll return that value. And then that will come into equals, which will be fully executed and it'll return true or false. So if we run the test, we have the same passing test for this where year. We pass in the year and then books. And what's so cool is, you know, maybe in the case where we are dealing with an API call, it makes sense to call these books so we know what we're talking about. But our transformation logic is really agnostic to that, right? So here we can use it with books, but then when we look at it, like we're not even, there's nothing about books in here, right? There's nothing about items. It's just high level flow, filter, takes an array, it uses a predicate function to filter elements, and it just returns that. So it predicate function to filter elements, and it just returns that. So while we're in here, it's common to, whenever you have a pipeline, it usually represents a discrete kind of unit of functionality, I guess. In this case, it's a really common operation to take a property and see if it's equal to another property, right? This is like a really common task. And so we're actually going to pull out that pipe and name it. And let's say year equals. And this will be a function that takes a year. Oops. And returns a pipeline. So we'll just say that it's year equals year. Pull that up. So now this is really declarative. We have filter where year equals year. Okay, make sure that works. Nice. And as you pull out kind of discrete units like this, we're saying, hey, pipe, this whole pipe thing really does its own thing. It becomes clear, at least to me, that this is really a generic function where, depending on year specifically, but if we just add one more argument, the prop name, in this case, we're hard coding the string year into the prop. But what if we just said, hey, we're going to make that dynamic too. We're going to make this a two-stage function where once we get the prop name, we return another function that takes the year. Once we have both of those, then we return this pipeline that's waiting for the object. So then we really just have a thing called prop equals. And now we need to, let's just say we want to make where year even more generic. We'll just call it where. Let's say where prop equals, because that's really the predicate function for the where-ness of it, like where we see in databases and stuff. So we want to get all the things where a certain thing is true. The predicate function is hard-coded to be an equality of a property and a given value. So we'll just say that this is where prop equals. Let's just say EQ here, and we'll get to why. So where prop equals, we'll take a prop name and then a value, and then we'll just say that we pass in, oops, prop equals, this will be prop name, and that'll be year. And this will be where prop equals, did I get this right? Okay. If I put a semicolon on, Prettier will take it off, cool. So now we're getting to another level of function composition where we have a lot of parentheses salad going on, which is an indicator to me that maybe we want to add another pipe. So let's check on our failing test because we changed the function name. And now we're just saying where prop equals, and now we will have to change how we work with this. But what's really nice is it'll probably just be one line of code. So in96 depends on where year, and from there we just need to make sure that works. So let's say where year equals where prop equals, and that is going to be year. So this is a three-stage function. It takes the property name, then the value, then the object. And now where year is preloaded with year, the name year, and that should work. Year is not defined. Oh yeah, we renamed year to value. Value. Cool, so the tests are back to passing. And now, like I said, just for fun, we can kind of show how lean this syntax can get. We can say, hey, really, we're just kind of waiting on the value to pass in. Is that right? Let's see. We want to call the prop equals function and then the filter function. But how do we get the arguments straight? So let's just say we're going to use a pipe again. And the first invoked function is prop equals. That's going to take some arguments. And then filter is going to pipe would close and then filter is going to take the result of that prop equals function. So this will be standalone because filter is just 2 steps, right? The predicate function. And we ultimately want this to be that preloaded predicate function. So now we need to decide, since prop name has to come first based on this function signature, we'll say that, we'll apply prop name here. We'll say that value comes last. So now prop equals already has prop name partially applied to it here, and then it's going to take its value. Forgot to do that here. Oops. So now we have prop name value, prop name value. So then this will result in this pipe that has those values preloaded. And now we had the same thing where the last argument in the function signature is just applied at the very end of another function. So we can delete, we can delete that value. And now pipe just is a function that is waiting for a value. And what it's going to do is return a filter that, or when we supply the prop name, it's going to return a filter function. It'll take 2 steps where we supply the prop name, that returns a function. Sorry, I lost my train of thought there. This is a 2-step function, takes a prop name, and then it returns a function that takes a value. Prop name will be eagerly loaded with this first stage, and then once we get the value, we'll actually execute the pipe, and this will turn that into a predicate function. The predicate function will get passed into filter, and that will return an overall function that's just waiting for a collection to run that predicate filter on for each round of the iteration. So make sure that works. And it does. That's really cool, in my opinion. This is like a really generic kind of, what it does is it points out that what we're doing is not super tied to books or years. And when we can start thinking of transformations as agnostic to their data, it allows us to recognize the same patterns across multiple domains. So next time I'm filtering in like a user's context or something based on, their email, the pattern is a lot more recognizable when I'm just focusing on this high level flow where, okay, I take a prop name and then I return a pipeline that's waiting on a value, and it's going to supply that to this partially applied function. It's going to supply it to that, which will return a partially applied function. And all of it was about composition and building up smaller functions in order to achieve a higher level goal. So like filter, really simple. Takes predicate x's, calls filter on those x's with the predicate. Equals takes an a and a b, says are they equal. Prop name takes prop name and an object, and it calls basically object.prop name. And then pipe is probably the most wild looking one, but it basically takes a list of functions, calls reduce, and for each function it takes an input, passes it in, and makes the return value of that function become the next y, the next function. Inputs become outputs. Prop equals is also a kind of integration function that takes advantage of pipe and prop and equals, but ultimately it's a 3-step function. A lot of times you'll see function signatures in functional, the pattern comes from functional languages, but in JavaScript you might see something like, hey, this takes a string and then whatever, and then because value could be an array, could be whatever, like a whole bunch of things. Takes a string and then an any and then an object that it can, and then it's going to basically, you wouldn't do this, but you'd say it calls object dot string, and then it says, hey, are you equal to any kind of thing. So this makes a little more clear how many arguments are involved. And in this case, we'd say it takes a string and then an any and then an array of objects. Do we do that? In this case, the object would be this object kind of thing. So again, it's very terse, it's very Spartan, and it is, it's a bit like self-congratulatory, but I do think that it, and you don't have to take it this far, right? Like being fully honest, like this is the most clear way to write this might actually just be to say filter prop equals prop name value, right? Like that's probably a little easier to read. Maybe not, but it's up to you to decide. The point of doing something like this is just to demonstrate how flexible functional programming and function composition is, because now say we wanted to have like 2 stages where we have a more complex equality matcher. Since this is a function, this itself is a function, we could kind of make a proof of concept where we take the string and we, instead of a named function, we have an anonymous function. And we could say that we're going to use the string here, which so this would take an object. So we might return an object. So this will be a curried function that takes an object. And what we're going to end up doing is passing the object, and we could, maybe we need to do something like, and like string, I don't know, do some like regex on it. Oops. Some crazy regex. What's cool about this is it allows us to test or kind of like slowly add things to the function. And if this became something that we needed to do, we could kind of pull this out to be a named predicate. So like const string validator or something, and take string and an object, and we could call it here string validator. Prop name, we'd have to pass that through. So again, it's the same patterns start popping up, right? Curried functions, bunch of arrow functions returning other arrow functions, then we can string things together. This wasn't a great example. The example I have in the blog is, so now we have this where prop equals function, and let's say, let's make sure we're still working here. Let's say we get a new requirement that we need to map all of these and return just the titles of the books, and they have to be lowercase, right? So in the for loop implementation, you know, if we're following that idea, do we then, okay, so we run a for loop and then we filter. Do we then run another for loop and then make another array and then like manually push things on? Or do we just add an abstract map layer to another pipeline that takes the result of where prop equals and then just takes those results? So maybe we'll do that in the next episode. Oh, but first, I forgot. What time are we at? 23:47. That's pretty long. But the good news is that filter and equals and prop equals and pipe, you don't have to write these by hand. It's good to see how they're written. Surrounding, I'm like trying to do all my somewhat, or no, I learned this recently. So with Vim, you can do yank surrounding, inner big word, no, yank surrounding, V around the quotes, and then I can wrap with F, a function, you see that on the bottom left, and I can say require, and it'll wrap it with parentheses. Kind of fun. Anyway, the filter can go away, equals goes away, prop goes away, pipe goes away, this goes away, and all the tests should still pass, and they do. So even though once we just kind of learn to develop an intuition about how these things can work, I don't necessarily have to know how filter works, and it might not be exactly how I explained it. And one benefit actually is that these don't have to be, these are technically auto curryable. So instead of having to do prop equals manually with 3 sets of parentheses, if for some reason I had the value and the object all at once, I could just pass it straight through in one go. So in the next episode, we'll show that example of extending the functionality with adding a map. We'll go ahead and call it here. What's overall, this was automated function composition, episode 6. Hey, how's it going? Good. I'm just recording a little video tutorial. But yeah, I'll be with you in just a second. All right. Thanks for tuning in. And yeah, again, in the next episode, we will take a look at adding map to that functionality.